Okay, all right. So today's lesson we're talking about integrating with respect to time. All right, so it's in the motion topic. All right, so previously, from previous lessons, you already know that if we have a displacement function in terms of time xt, and if we differentiate, then we're going to get a velocity function in terms of time vt, or x dot t. All right, so the process here is differentiation. You differentiate with respect to t, d over dt xt function, and then you are going to generate a velocity in terms of time function, or vt, or x dot t. All right, then if you differentiate one more time, find the change in velocity with respect to the time, then you are going to get acceleration in terms of t. So you can write at, or you can write v dot t, or you can write x double dot t, and that will be acceleration in terms of time. All right, so you've got an acceleration function. Now, today's lesson we're going to go backwards. All right, instead of differentiation, we're going to go the other way, which is the antiderivative, and that's integration. All right, so if we're going backwards, all right, once we are given the acceleration function, we can integrate with respect to time to get a velocity function. And then if we're given a velocity function that we can integrate with respect to the time, we can get a displacement function. All right, so going backwards is just integration. All right, so if we integrate a with respect to t, then we are going to get a velocity function plus c. And then if we integrate with respect to integrate velocity function with respect to t, then we are going to get a displacement function and plus c. All right, so this is just a relationship. Now we're going to do some questions. Okay, let's start with questions. Okay, let's have a look at the first question. All right, question 1. So a particle moves from x equals to minus 1 with velocity v equals to 1 over x t plus 1. And then the question asks you, how long does it take to get to the origin? And what are its speed and acceleration, okay? All right, so what are its speed? So what are the speed and acceleration? All right, so how do we do this question here? So like everyone, just have a look at the given condition. We have a particle that moves from x equals to minus 1 with velocity v equals to 1 over t plus 1. So we have a velocity function in terms of time. We know this is the initial condition. This is where the particle starts from. All right, moves from that point, which is to the left-hand side of the origin. This is the starting place. All right, starting place. And then this is the velocity function vt. All right, now the question asks you for how long. So the question asks you the time to get to the origin. Now, the origin is when x equals to 0. So this is the idea, all right? So the question asks you how long it take. So when x equals to 0. So basically, the question asks you the time when x equals to 0. So xt, you need xt function, all right? The displacement and time function. You are given the velocity and time function. So all we need to do is integration. So we integrate velocity function in terms of time, and we are going to get displacement function. All right, so let's start with this. All right, so x is equal to, when you integrate 1 over t plus 1 dt. you're going to get x equals to ln absolute value t plus 1 absolute value plus c. Now this time it's really important that you know that you have to make sure that c is there, because you are going to use the initial condition to work out the c. All right, so how do we find that c? What do we have, all right? How do we get to c? All right, yep, so xt, yep. So how do we do it? Initially, so this is the starting position, right? Initially, when t equals to 0, x is equal to minus 1. So negative 1, or 1 unit to the left of the origin. Now we can do a substitution inside here. Okay, so if we substitute t equals to 0, x equals to negative 1. Negative 1 is equal to ln 1 plus c. ln 1 is equal to 0, so c is equal to minus 1. All right, so once we get c equals minus 1, then we have a function that we need, all right? The function is x equals to ln t plus 1 minus 1. All right, that's the function we have. And now this function is the xt function, the displacement and time function. Okay, so what does the question ask us to do? How long it takes to get to the origin? So we just need to work out when x equals to 0, all right, what is the time? Okay, so when x equals to 0 here, all right, what does the time equals to? All right, let's solve this question here. So 0 is equal to ln absolute value t plus 1 minus 1. So ln absolute value t plus 1 is equal to 1. Then absolute value t plus 1 is equal to e. So t is equal to e minus 1. Now we can get rid of the absolute value because t is always a positive number. You don't have to worry about whether t is going to be a negative number or not. Yes, and that is the answer here. All right, t is equal to e minus 1 second later, the particle or the object will get to the origin. Now the next part of the question asks you, what are the speed and acceleration? Speed and acceleration, all right? So to find the speed, we have the velocity function v here. We just need the time, right? So all you need to do is to substitute the time e minus 1 back into this equation. You should be able to find out the speed. All right, so the speed at that particular time is 1 over e minus 1 plus 1, which is 1 over e. That is the speed. How about acceleration? Well, do we have the acceleration equation here? No, we don't. So what we need to do is to find the acceleration function. And how do we find it? We have the velocity function. Now remember this. From displacement to velocity is differentiation. From velocity to acceleration is differentiation as well, right? So we differentiate. All right, so we need to differentiate velocity function. D over, use a different color. D over dt, 1 plus t plus 1. All right, we need to differentiate that expression here, and we can get the acceleration formula, all right, or acceleration function. So acceleration is equal to, all right, to differentiate that one, it's pretty easy. Negative 1 over t plus 1 squared. That is the derivative. Now also we'll get that point, all right, we need to find the acceleration when the time is equal to e minus 1. So we'll do a substitution. That gives us 1 over e squared. And that becomes the acceleration. All right, so we have the speed here, which is equal to 1 over e. We have the acceleration is negative 1 over e squared. And we have, what else we have? We have an equation in terms of x and t. Now, if I want to describe the motion, as you can see here, the speed is positive, which means the particle is moving in the positive direction. All right, and then acceleration here is negative, means the particle is slowing down. All right, so that's the question, first question here. All right, using integration to find the answer. Okay, let's move on to the next one. All right, question B. Let me find a question. All right, how about this time? Let's do a question in terms of trigonometry. All right, so trig functions. Let's do this one here. Question B. A particle, all right, or a moving particle, all right, is subject to acceleration, which is equal to that formula here. That's t. All right, and that's t cos t meter per second square. Initially, all right, so initially it is at x equals to 2. And then moving with velocity 1 meter per second, and it travels for 2 pi seconds. All right, so this is the question. We've got a particle. It's subject to the formula, the function, acceleration function, a equals to minus 2 cosine t. Initially, it is at t equals to 2, moving with velocity 1 meter per second, and it travels for 2 pi seconds. Okay, so the first question asks you to find function v and x. All right, so we need to find the function vt function, and we need to find xt function. All right, find v function in terms of time, find displacement function in terms of time. All right, so how do we do it? We'll have this function here. That's acceleration function. We can find the velocity function and the displacement function by integrating it, okay? Now we need to look at the initial condition. We have so many initial conditions here. And I'm just going to write down initial conditions here. So I'm going to use it to find the c after integrating it. When t equal to 0, initially means when t equal to 0. X equal to 2. That's a displacement. Moving with a velocity equals to 1. All right, and then it travels for 2 pi seconds. All right, that's a total time it travels. So that might be used for the later question. All right, so let's start with this. The VT equation, V is equal to integrate the x double dot, okay, which is the acceleration function, negative 2 cos t dt. All right, so we need to integrate negative cos t. That gives us minus 2 sine t. Or integrating cosine, it's sine, plus c. All right, so we need to work out what's c. How do we get to c? Well, we have the initial information here, right? So when t equals to 0, v equals to 1. We can do a substitution. So 1 equals to minus 2 sine t plus sine 0 plus c. Sine 0 is equal to 0, so c is equal to 1. All right, so the velocity function is negative 2 sine t plus 1. That is the velocity function. All right, so once you get to the velocity function in terms of time, we need to now integrate this one more time to get displacement function. Displacement function, it means you integrate this one more time. All right, so you integrate velocity function one more time, negative 2 sine t plus 1 dt. All right, so if you integrate negative 2 sine t, it's equal to positive 2 cosine t plus another c. Let's just call that c2. All right, now we need to find c2. We have another condition here. So we substitute. When x equals to 2, t equals to 0. Now cos 0 is equal to 1, so that gives you 2. And that's 0 plus c2. So now we know c2 is equal to 0. All right, so finally, after integrating this one twice and substituting the numbers twice, we find out two equations, right? So x equals to 2 cosine t and plus t. That is the displacement time function. So we'll have three functions now. Acceleration and time function, displacement time function, velocity time function, and displacement time function. So three functions here. All right, let's have a look at what's the second part of the question. So this is the part A. Now, have a look at part B. All right, part B, question says, when is the acceleration positive? All right, when is the acceleration positive? How do we do this one? When is the acceleration positive? Well, that's acceleration, right? We need to make sure that acceleration is positive. And then the question asks you when. All right, what is the easiest way to do that? Well, acceleration function, first we'll write this one down. What you can do is just sketch the function, all right? You can sketch this trigonometry function here. So this is just a cosine function. 2 pi, pi over 2, 3 pi over 2. All right, now cosine function right now, it's oscillating between 2 and -2. So the function looks like this. All right, and then it travels for 2 pi seconds, which means this is t, that's the acceleration. Now the question asks you, when is the acceleration positive? Positive. Positive means above 0, right? Above 0. So this part is positive. Here is also positive. So to answer this question, it's super easy. All you need to do is sketch a graph. All right, so when is the acceleration positive? When t is between 0 seconds and pi on 2 seconds, the acceleration is positive. And then when t is between 3 pi over 2 seconds and 2 pi seconds, the acceleration is also positive. All right. All right, we're going to move on to the next one. All right, question C. So as you can see here, although this one is like a motion question, but you are going to use the trigonometry to solve it. All right, okay. Let's move on to question C. All right, question C. What's the next question? All right, so the next question asks you when and where is the particle stationary? When and where is the particle stationary? Okay, stationary. What does stationary mean? Stationary means the particle is not moving, okay? Stationary means the particle stays the same, it's not moving, it's stable. Okay, so that means the velocity is equal to 0. So velocity is that. And the question asks you when and where. All right, so what we need to do is to work out the time. All right, and we're going to work out where. All right, where's the location? So we're going to let v equal to 0, right? Stationary velocity is equal to 0. So let velocity equal to 0. So we'll have the velocity function here. -2 sine t plus 1 is equal to 0. Sine t is equal to half. T is equal to pi on 6. That is the first answer. All right, so the particle is stationary when t equal to pi on 6. And our second answer is pi minus pi on 6, which is 5 pi on 6. And it's still between 0 and 2 pi. So these are the time that the particle is stationary. All right, now where is the particle? Well, all you have to do now is do a substitution into the t, okay, into the t. So you substitute when t equals to pi on 6 into both these two t's here to work out the x, and then you're going to substitute 5 pi on 6 into both these two t's to work out the position of the particle. All right, so therefore, the first one is x is equal to 2 cos pi on 6 plus pi on 6. Cosine pi on 6 is root 3 over 2. And if you cross this 2 out, it becomes root 3 plus pi on 6. That is the position away from the origin. All right, so you can do the same thing for the 5 pi on 6 and do a substitution. You should be able to find out the x. Okay, so I hope this question will give you some idea how do we deal with like question in terms of velocity, acceleration, and displacement. Basically, all you need to do is to integrate the acceleration function, so you get the velocity function, and you integrate velocity function, you get displacement function. Once you have all three functions, then you should be able to solve the question based on what the question asks you to do. All right, so it's all of them is just substitution, all right, solving equations and substituting the numbers back to get the certain answer. But the most important thing is the process is integration. All right, so when you're integrating it, you're going to get from acceleration to velocity to displacement function. Okay, all right, so that's all I want to teach you this lesson. I will teach you more about this later on. All right, so make sure you subscribe my channel, and thank you.